So my name is Heinrichs. I'm the technical lead for the JavaFX core components, and today I want to talk a little bit about JavaFX. But before we start, I'd like to ask some questions. So who has used JavaFX so far? JavaFX 2? Okay, that's a little less than I expected. Who has used JavaFX 1 version? That's at least some people. And who has used Swing? Yeah, that's the vast majority. Okay, and who plans to use JavaFX? Okay, at the end of this talk, I want everybody to raise their hand, okay? So, let's take a look at the agenda. So, I want to start with showing you a couple of examples, just to show you for how many use cases you can use JavaFX and how flexible it is. Then we'll take a look at a short Hello World script, with which I want to show you what it feels like, what a JavaFX application looks like. After that, we're looking to two major concepts in more detail. The scene graph, which is the most basic data structure that you will need for every JavaFX application. And then the animation API, which you can use to animate the objects on the screen or even animate your own objects and properties. And towards the end, I'll go briefly into some more features, but I'll just keep that short because of the time. Okay, before we start, a couple of words about me. So I live in Prague. I come from Germany, but I moved here a little more than 4 years ago. I have 2 daughters with whom I like to spend most of my free time, and I enjoy cooking. But what's probably most important, how am I involved with JavaFX? So when I came here to Prague, I joined Sun Microsystems, and my very first project was the JavaFX script compiler. So at that time, JavaFX was not only a library, but also a new language, JavaFX script, which we developed, and the JavaFX script compiler would take a JavaFX script program and compile that to bytecode. So you could run it on any Java VM. That was my first project as Sun Microsystems. After about half a year, we figured JavaFX would be much more powerful if it runs not only in desktop, like we planned originally, but also on mobile devices. So we created a new project, JavaFX Mobile, in which we tried to run JavaFX applications on mobile devices. Shortly after this project was started, I joined that team and I was responsible for performance optimization. So I think I never wrote any new functionality on that platform, but I was just looking at the runtime and tried to improve it. And about is it 1 year or 2 years now, the acquisition? 1.5 years. Okay, so after the acquisition of Sun Microsystems by Oracle, we looked at JavaFX together with Oracle to decide what to do with this project. This was pretty much done with all projects at Sun Microsystems, and certainly also with JavaFX. So in general, they liked the idea, but they wanted to pretty much change everything. The new language was totally dumped, and we had to rewrite the whole library in pure Java. And during this restructuring, the teams were also set up differently. I became the technical lead for the JavaFX core components. The JavaFX core components are the new JavaFX properties, which extend the Java Bean properties, new collections we implemented in JavaFX, and the animation library and the binding API. So basically the basic data structure that we use throughout the runtime, these are the core components that I'm doing most of the time. Okay, I work with Oracle, so I have to show you this. Yeah, so you need to read it, and I have some documents you have to sign afterwards. No, just kidding. So what this says briefly is I'm not really allowed to give any commitments or anything. So if a date or something slips out of my mouth during this presentation, you are not allowed to run home and base your business plan on that, which totally makes sense. I think everybody plans that. So, and if you do, and these are not commitments, then you cannot sue Oracle. So let's get over with this. So when I started to look into this presentation, I looked at the official definition, what is JavaFX? And I have to read it. So JavaFX is the evolution of the Java-rich client platform designed to provide a lightweight, hardware-accelerated UI platform that meets tomorrow's needs. So everything that's written up there is totally true. But when I come to the end of the sentence, I pretty much forgot the beginning. So instead I thought, to explain it, what is JavaFX? JavaFX is swing and cool, just brief as that. Now I don't want to say that swing is uncool. You can do really amazing things in swing, but I think you really have to be an expert, and only very few people are able to do this. And with JavaFX, pretty much everybody can write really good-looking, great UIs. So let's take a look at some of the examples. With JavaFX, it's really easy to write amazing-looking graphics. I mean, this looks pretty awesome, actually, but in JavaFX, I think it's just 10 or 20 lines of code. It's really, just a bunch of circles, some gradient, playing with the transparency, and that's it. And it's really easy to do this in JavaFX. But JavaFX is not only about really great-looking graphics and fancy-looking demos and this kind of stuff, but JavaFX is also very good to write business applications. I think the priority now with Oracle is even higher than it used to be under Sun, because Oracle's main business is writing business applications. So they want to make sure, that we focus a lot on helping developing business applications. So we have a bunch of controls. We have a lot of charts. So Oracle doesn't only want to store your data, they also want to show it to you. And for these, we have these charts. And I think these are actually, this is the default look. So it looks actually quite, kind of neat already out of the box. You can write games with JavaFX. Seeing this, I have to remember we implemented this game on a couple of tablets for Java 1 last year. And towards the end of this project, the question was, so who's going to test it? Because you want to make really sure it doesn't crash during a keynote, right? And the people on the team didn't want to play it anymore because they were just tired of this game. So the question was, what should we do? And one Friday afternoon, my boss just took the tablets, and when he went to his parents in Slovakia, he gave the tablets to his kids in the back to play with it during the car drive. And when he came back on Monday, he was just stoked. He was so excited because not only the applications proved to be stable, they didn't crash, it was the most peaceful and quiet ride he ever did to his parents in Slovakia. Okay, yeah, I want to demo this. So JavaFX is also very cool to play media. Without any doubt, playing media in Java was always a huge issue. But with JavaFX, it's really simple. You can play a video on the screen using 3 lines or 2 lines of code, something like that. It's really just creating a class, passing the URL where the media stream is, and that's it. You're done. And the rest is done in the API. And because it's totally embedded into the scene graph, I'll talk about this a little later, you can apply all kinds of transformation and effects on video and implement this kind of rotating cube playing video. So just to prove to you that we can really play video now in Java. Okay, so these were just a couple of examples to show you how broad the range of applications is you can actually use for JavaFX. So let's take a look at Hello World script. So it's not like a typical Hello World script, it does a little more. There's a button in this application, and when you press it, it prints Hello World to system out. I chose this application because it is the standard or the initial project when you create a JavaFX project in NetBeans. So for a lot of people, or for those people who use NetBeans, this will be probably the first JavaFX program you ever encounter. So this is the full program. Let's look at this step by step. So in the first line, up here, you can see that we have to extend application. That's a class that's provided with the runtime. And it is an abstraction to make the life cycle management of JavaFX applications easy and straightforward to use. Because you just extend this application in your JavaFX class, you implement some methods like init, start, stop, and then depending on your compilation flags, this will work as a standalone client application, or it can be run as an applet, or it can be run on tablet. And you don't have to deal with the different lifecycle models all of these platforms have. You just use application, and your JavaFX program will always look the same. So we extend application, and we have to implement the start method because that's the place where you initialize your application. But before we do this, we have to look at this little main method here, because we want to be able to start our application from the command line. So we have to implement the static void method, and we just call launch with the command line arguments, and this actually starts the runtime, makes sure that the animation system is working, that the scene graph is set up, and once everything is set up, the start method will be called by the runtime. It passes in a stage, which is kind of your initial window, which you have to fill with content in the start method. So first thing we do is we set the title of this stage. And here you can already see this is very much like in Swing and almost all other libraries. JavaFX depends a lot on properties. So there's a property title, and there's a setter, set title, a getter, get title, and you can use that to access this property. Next, we create the button. So there's a class button which we need to create. Then we can pass in the text. This is going to be the text that's written on the button, and then we create an action listener. So when you click this button, we call system out and say hello world. Now for button, this looks actually very similar to what you're used to from Swing, but actually the event handling is very different in JavaFX compared to Swing. Because in Swing you often have, for something like a mouse listener, you have an interface with a lot of methods you need to implement, or you use an abstract mouse listener and you just extend the methods that you need. In JavaFX, every event needs its own class or its own event handler. So if we talk about a mouse listener, there's an on mouse down that needs, or an on mouse down property that needs its own object. There's an on mouse up property that needs its own object, etc. And this certainly looks kind of weird when you look at it the first time, because it's a lot more code you need to write. But actually the plan is the idea is that this is, once we get lambda expressions in Java 8, this becomes a lot easier to use, because with lambda expressions, the whole event handler would just look like this. You just pass in the parameter and the method body, and the compiler does the rest. It creates this anonymous class, etc., and figures out which one to use. So once we get lambda expressions, JavaFX becomes a lot more easier to use. It's already ready for lambda expressions. But we are still stuck with Java 7, so we have to write a little more code. Okay, and then we create the root node, and I have to explain this a little more. So as I said in the beginning, the stage is kind of your main window when you write a standalone application. When you use an applet, the stage is again the outermost frame for this applet. Within this stage, you put a scene, and that's the content, where you have the content. And within this scene, you put the scene graph. And I'll talk a little bit later about what the scene graph is. But this is how an application is structured in JavaFX. You start with the stage, you put there a scene, and in this scene, you define a scene graph. And that's what we're going to do here. So stack pane, that's the root node of our scene graph. It's just a parent node, which also does some simple layouting. And it has a property, children. And when you get this is a list, and you just add the button. And with that, you have the root node and the button attached to it as a child. And last but not least, we create the scene back here. pass in the root node, the width and the height. It's here. Set this as the scene of the stage, and then we call stage show to make the main window visible. And that's pretty much it. So that's the Hello World script. Okay, so let's look at the scene graph now. Well, every UI in JavaFX is implemented using a scene graph. So what is a scene graph? When you have some kind of UI, you have a lot of elements on the screen, and now you can structure them. So for example, here, I want to put the image and the label in one group together, and I want to have those stores in another group. And just do it like this, and with the groups, I put them again together in a group until I have a full tree. And that's the scene graph. So it's very common in other environments. So if you use, for example, the DOM in HTML is pretty much like that. Or when you do 3D graphics, it's almost always using a scene graph. And JavaFX is providing a scene graph for Java 2D, for 2D graphics. And what's so powerful about this concept is, once you have this scene graph, you can actually take any of these nodes and ignore everything that's below it. And you can apply, animations, you can move it around, you can rotate it, you can translate it. And the runtime makes sure that all of the child nodes look appropriate. You don't have to worry about it. For you, this group up there, this one, for example, it's just a black box. And that there's actually an image and a text together, you don't have to worry about that. So the question is, the scene graph is used for all UIs. What are the possible leaf nodes? Because that's what you need to define your user interface. So as we've seen, we have images, and then we have shapes. There are a bunch of predefined shapes, like the rectangle, circle, and the ellipse. But you can also define your own shapes, using a path library similar to what's possible in SVG or Dojo if you use JavaScript, for example. And so with that, you can define a triangle, but even much, much more complex shapes. And then you can change the color of those shapes, the filling. You can use linear gradients and radial gradient. You can change the color of the stroke and the width, and you can even use dash strokes for your shapes. We can show text. You can use different text fonts. You can use different colors for these fonts. And yeah, WebView is a new node which was not available in JavaFX 2, not available in JavaFX 1, but it's brand new in JavaFX 2. And I think it's one of the coolest new nodes that's available. Because with WebView, you can actually show web content in Java applications. And it's extremely simple to use it. You pretty much just define a web view, you pass in a URL, and then it shows it on the screen. And again, it's a scene graph node, so you can do whatever you want with it, move it around, animate it, and all that kind of stuff. Media, we already saw that. That's just another node within the scene graph, so you can do all kinds of tricks with it that are possible for the other leaf nodes as well. Then we have a lot of controls, and these are actually not really leaf nodes, but they are defined as using the basic shapes. So for example, these buttons are just rounded rectangles and a text box. But as a user, you don't have to worry about that because, as I said before, it's just the subtree which you can totally ignore. For you, this button is just a black box, and that there is actually a shape and this text inside doesn't matter to you. So we have a bunch of controls and charts as well. They're not really leaf nodes, but for you they behave like that. So these were the leaf nodes. Now let's take a look at the parent nodes, because there is also some additional, there are actually a bunch of implementations. So group is the simplest implementation, because with that you just structure your scene graph. They don't have any side effects. But then there are actually nodes which you can use to lay out the child nodes. So just there's some simple one, HBox for example, takes all of the children and lines them in one horizontal one horizontal line. And there's also a VBox which does the same for a vertical alignment. But there are also certainly more advanced layouts like the grid pane and border pane and stuff like that, with which you can actually do pretty complex layouts already. And that's pretty much it for about the scene graph. So now let's take a look at the animation API and how you can actually do all of these fancy effects, the Java leaf node, or all of the nodes in JavaFX allow to do. So the animation library provides several approaches how to define animations, and the simplest approach are the predefined transitions. A predefined transition actually allows or enables you to define one specific type of animation in a very simple and straightforward way. So for example, there's a translate transition, which just takes a node and moves it around on the screen. And to define something like this, you just create this translate transition, then you set a bunch of properties like the node, the start and the end point, and the duration, and that's it, you're done. And then you have methods like play, pause, and stop, with which you can actually run this animation. Or you can jump around, you can play it in a loop, you can play it backwards and forward and backward, you can play it faster and slower, and all of that is already implemented. You just create this translate transition, define the node you want to animate, the start and the end point, and the duration, and that's it. There are other predefined transitions like the rotate transition to rotate a node, and fade transition which allows you to play with the opacity. Now these predefined transitions are really easy to use, but they have a major drawback because they just allow you one specific type of animation. And if you want to do something more advanced, something more complex, or if you want to animate your own properties in your own classes, you can use a timeline. So what is a timeline? Timeline consists of, or has a certain duration, let's say 1 second. And then you mark certain positions on this timeline, which we call keyframe. So if you've ever heard the term keyframe-based animation, that's what timelines implement. So we have these positions, keyframes, and on each keyframe we can now define key values. And a key value is a tuple of a property that you want to animate and a value that you want to reach when the animation reaches this exact keyframe. So here we have 3 keyframes and 3 key values. In the beginning, the value is low at 0. In the middle, it is somewhere here. It's still a very low value, and at the very end, your property is up there. And the values in between are going to be interpolated. So what does it look like? If we animate this little star, we can just play this animation, and you can see how the pointer is showing the position on the timeline, and the value that is calculated and interpolated changes the position of the star. Now that's pretty much all we had for JavaFX in JavaFX 1. I mean, we also had some easing interpolation, but it was pretty much all we had. And about 1 year ago, we got a new team member. And the interesting thing is that he's not a developer, but he's actually a professional animator who used to work at Disney. So he was working on some of the animated 3D movies that you have seen, probably. And he looked at our animation API and he told me pretty much, that looks very nice, but it's totally useless. I can't work with that. And I certainly did what every developer would do in this situation. I told him, no, it's perfect, you just don't get it. It took us a while, and after a while he convinced me that, yeah, he's right. Although this is all we had for almost 2 years and everybody was happy with it, it was totally insufficient for really good looking animations. Because the issue is this point. Up until here, the animation runs really slow, and all of a sudden it becomes really fast. And even using some ease in and ease out doesn't really help in this kind of situation. So we sat together and tried to define a new concept, how we can actually tackle this to make these animations better looking. And what we came up with was this tangent interpolation. So now you can actually define how the tangent, oh, I can see it if I show it right. So you can define the tangent of the interpolation for each keyframe. And with this, you can actually define really extremely smooth animations. Unfortunately, my Keynote skills don't really, are not really sufficient to show how this looks animated. Sorry about that. But with this change, now this animator is happy with the animation API. And I think that's pretty unique. So the JavaFX animation API is sufficient enough to make a professional animator happy. Okay, CSS. That's we're coming to some more features. Actually, I want to demo this, which I'll just show briefly. Where is it here? Okay, let me just put this away. So here we have a window with a bunch of UI controls. And now when I press this button, the appearance of the whole window changes dramatically. So here's another style. And the interesting thing about it is the Java code that's being executed when I press this button is just one line of code. I'm really just switching the CSS style sheet. And look at what we can actually change here. Now look, for example, at these buttons. When I change it, I can actually change the shape of a button just using CSS. I mean, we change the font, the colors. All of that is possible in JavaFX now. Okay, let me get back to the presentation. So when I first heard that we're going to implement CSS for JavaFX, I thought, what the, because in Java you can do everything. It's not like HTML where you need some help from outside or something. You can do all of this in Java. So I was wondering, why do we need CSS? But actually, it's a pretty cool feature, I came to realize. Because it helps you to split the work between designers and Java developers. How did it work in the past, usually? Your designer wrote the UI specification as a Word document, for example, passed it to you, then the Java developer would just hack this, send the result back to the designer. He would look at the application, notice that there are some changes required, fix the document, pass it back, and with this, even a simple window could take days to implement. But now using CSS, it's just a matter of hours, because the issue is designers don't know how to code Java very often. I mean, they have different skills, right? They know how to create good-looking UIs, what most Java developers don't know how to do. So, but they cannot use Java. But most designers know how to write CSS because they write HTML or websites. So now with using CSS, the designer can actually do his changes by himself. You just give him a stable build that picks up some style sheet, and then he can hack his changes into the style sheet, and he sees the results immediately. So what used to take days because you had to pass stuff back and forth and wait for the other guy to finish his work, it just takes just hours, because the designer sees immediately what he needs to see, and the Java developer is actually not being bothered by this stuff at all. So, pretty cool feature. Here you can see how it looks like. So this is really taken from some real JavaFX application, or actually I think it's taken from the default CSS file. So how does it work? So for example, let's take a look at this selector. We have an ID page tree toolbar. So within the scene graph, there's somewhere an object that has all of the nodes in the scene graph have an ID property, and one of these nodes has the ID set to page tree toolbar. And below that, because remember we're in a scene graph, so we have a structure. Below that, there are objects that have the style class set to toggle, or have the toggle button within their style classes. So again, that's just a property in the Java code, and when you set toggle button there, it will be picked up by this selector. And below that, we just look for all instances of text. So text is just the Java class. And with that, we can actually pick pretty much every node in the scene graph and do pretty amazing queries on the JavaFX scene graph. And if you know CSS from website development, this looks pretty familiar, I think. And you can pick it up quickly. Okay, WebView, another really awesome new component. I already talked about it, but actually now I want to show it to you, just in case you don't believe me. So here I have a little browser. Let me just change the URL. So it's JavaZZ. Okay, let's try that. So now we have the Java website here. And this is actually a Java application. So this browser is a Java application. And not only that, you can see on looking at the name, it's actually a Swing application. So here you can see a Swing application working as a browser. And which leads me actually directly to the next. Oops, why? Oh, okay. I'm already on the first screen, did notice. Which leads me to the next topic, Swing integration. Very important for the people here who think, okay, JavaFX is really awesome, but how can I use it? I have a Swing application at work, and I can't just, rewrite it in JavaFX. It doesn't work. And for that, we have a panel, JFX panel, which helps you to use JavaFX features in your Swing application. And what does it look like? So, for example, if we have a JFrame or something like that in Swing, we just add a JFX panel. That's a new JPanel, which is part of the JavaFX runtime. You just put it in your JFrame, and within that you can define your scene, and within that your scene graph. So it looks almost like a typical JavaFX application. And that's how you can actually use JavaFX features in your current Swing applications if you want to show, for example, a web view in your Swing application. Okay, and there's more. I'll just go through it quickly. So since JavaFX is just a Java library, it works with pretty much all the languages that run on top of the Java VM. So if you're implementing or if you're using Scala, Groovy, JRuby, JavaScript, or whatever, these languages usually provide mechanisms how you can call standard Java classes. And since JavaFX is a Java library now, you can just use it with any of these languages. But there are actually community efforts going on to make it the experience even better. So if you're using Groovy, there's GroovyFX. If you're using Scala, there's ScalaFX, which add some stuff to make it feel more natural in these languages. So unfortunately, I cannot really use it in my daily work. I have to use Java, but I heard that these plugins are really cool, or these projects. So if you are able to use it and you want to use these languages with JavaFX, I recommend to look at these projects. The next thing is IDE integration. Again, JavaFX is a standard Java library, so it works out of the box with any Java IDE. So everything like debugging, profiling, everything works out of the box. No worry about that. But actually, for NetBeans and Eclipse, there are plugins being developed. For NetBeans, since NetBeans 7.1, I believe, the plugin is actually part of the standard installation. And that helps you and makes it even more fun to develop JavaFX application in NetBeans. And for Eclipse, there's also a plugin which is developed by the community, and that helps you as well to develop JavaFX applications. fXML is another interesting new topic. So with Swing application in the past, there was also always an issue when you used a tool to create your UI, your user interface. Because in Swing, you had to design or you had to implement your user interface in pure Java code. So every tool had its own kind of mechanism how to do this. There were some protected code sections which you were not allowed to touch, which were just maintained by the IDE. And the main issue was actually that there was no standard. So if you created your UI in NetBeans, you were not able to use it in Eclipse, for example. So if you had a huge team, everybody had to use the same tool to design the UI. And once you committed to use one certain tool for a project, you were actually not really able to switch to a different tool because it would require a lot of work to do that. Now with fXML, we specified an XML dialect with which you can actually define any kind of JavaFX UI. And the idea is now, for example, if one developer builds some window in NetBeans, it's being stored in fXML, and then Eclipse can just pick up this fXML and use that out of the box to display the window. And everybody in the team can now use his own UI, and you can switch within the project as much as you like. There are people who prefer to define their UI in XML. I don't do this, so I prefer to write my UIs in Java, but just want to mention that people do this, and actually I think it's pretty much straightforward. As you can see here, there are the classes with the properties you want to define. Here's a, I hope we aren't locked in now. So here's the children property, and this anchor pane, it's just a layouting pane, has one child, a button, and again you can see the different properties specified here. So you can actually read this code and you understand what this UI would look like. Okay, so that's pretty much it. We started by looking at some examples and saw how you can use JavaFX to create great-looking graphics and games, but also to use it for business applications, having a lot of UI controls and charts. We looked at Hello World script just to get a feel what JavaFX application looks like. And then we looked into two concepts a little bit in more depth, the scene graph and the animation API. And then we looked at some more features briefly. So what's next? I hope I convinced you that this is really interesting and you should give it a try. So there's a JavaFX website. Here you can download the JavaFX SDK, and there are a bunch of tutorials and the documentation, and there are developer builds. So if you're using Linux or Mac, you can download that now and use JavaFX on these platforms. If you have questions, there's the Oracle forum. There's a specific thread for JavaFX 2.0, and pretty much a lot of people from the JavaFX team and a lot of people, active people in the community, are watching this thread. So if you have any questions, I think usually you get an answer within 24 hours on this thread, and very often from the people who actually implemented the stuff you're using. If you found a bug or if you have feature request, we use Jira for that, and there's a public, it's public, so you can enter any request. For API discussions, we have the public mail alias. So here we're discussing future ideas, but also really concrete API changes, or not changes, we are compatible, but API additions that are being implemented right now. So you're invited and to join this alias and take part in these discussions. And very soon, JavaFX will become a real open source project. We announced it at Java 1. JavaFX is going to be open sourced. We are currently in the process of putting the sources into the open. Large parts are already available, and others will follow shortly. What we're kind of lacking right now is the process, how this will look like, and this is being defined. And it will probably look like in most open source projects. So if you want to actually participate and commit to the OpenJFX project, you're invited to do so. And down here, this is my Twitter handle, and this is my blog, in case you want to follow that. Most of the time, I'm writing about JavaFX. And that's it from my side. Are there any questions?